Okay, day 23. Let's hop on it. Starting configuration. Alright, so this looks like it's going to be our sample data. So let's go ahead and throw that in here. Okay. And we're trying to seek out the least energy required to organize. Okay? Group of timid, stubborn amphipods live in a nearby burrow. 4 types: amber, bronze, copper, desert. They live in a burrow that consists of a hallway and 4 side rooms. The side rooms are initially full of amphipods, and the hallway is initially empty. Diagram situation, including locations for each. All's open space. The amphipods would like a method to organize every amphipod into side rooms so that each side room contains one type of amphipod and the types are sorted A through D, going left to right. Amphipods can move up, down, left, or right so long as they are moving into an unoccupied space. Each type of amphipod requires a different amount of energy to move one step. Amber amphipods require 1 energy per step, bronze 10, copper 100, desert 1000. However, because they are timid and stubborn, the amphipods have some extra rules. Never stop on the space immediately outside any room. Move into that space so long as they immediately continue moving. Okay. Never move from the hallway into a room unless that room is their destination room, and that room contains no amphipods which do not also have that room as their destination. So you can't bounce around. Once an amphipod has stopped moving in a hallway, it will stay in that spot until it can move into a room. Because once any amphipod starts moving, any other amphipods currently in the hallway are locked in place and will not move again until they can move fully into a room. For example, the amphipods can be organized using a minimum of 12,521 energy. One way to do it is as shown. That B moves there. That C moves over into C. Okay. D moves out of the way and the B moves down. Then the B moves over. D has to go up and left because the A has to go up and right because otherwise it won't work. What's our actual puzzle input look like? The same kind of thing. So that's kind of interesting. Same kind of thing. These rules obviously add a constraint that probably actually helps us. Really, the question is going to be, though, how to use those rules to our advantage. It is interesting that the current solution does not ever exploit the fact that this is a double space versus these spaces, which are single space. So B moves out of the way, C drops in, D moves out of the way, B drops in, B pops over, D moves out of the way, A moves out of the way, D drops in, D drops in, A drops in. I honestly have no idea what this kind of an algorithm actually is. So that is the same. I really have no idea what this algorithm is called. The question is, do I just do it by hand and come up with an answer? It might work for part 1, but that's not going to work by part 2. I'm pretty much guarantee that. Because obviously A's are basically free to move, right? So you could take a look at this and move this A over here, move this A over here, move this C here, drop this B into here, move this D up, drop this B into here, move this D down, move that D over, right? I just, I don't know what an algorithm for this looks like. I'm being honest here, right? So you go here. So that's 1, 2, 3, 4, 5. So it's A times 5. And you go 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. So we can do that. And that gets us an A times 6. Now we need C and B to swap. The cheapest way to do that is to move B up here. So 1, 2, 3. So B times 3. All right, so that's where B goes. And now our C is 1, 2, 3, 4, 5, 6. So our C goes 6. And then we move our B 1, 2, 3, 4, 5. So we move B 5. All right. We move D out of the way. So there's 2 for D. All right. And then we can drop B. Let's see, 1, 2, 3, 4, 5, 6, 7. 7 spots for B. B times 7. And then D is going to move 1, 2, 3, 4, 5, 6, 7, 8, 9. D times 9, which then is D times 2. All right, and then C, 1, 2, 3, 4, 5, 6, 7. C times 7. And then A, 1, 2, 3. And again, A, 1, 2, 3. So A times 3 and A times 3. And A times 3. That looks like the best possible answer, right? So this is 5. This is 6, this is 30, this is 600, this is 50, this is 2,000, this is 70, This is 9,000. Wow, that's really expensive, but you know, what can you do? 2,700, 3, and 3. 5, 6, 30, 650, 2,070, 9,000, 2,700, 3, and 3. 20767. Choosing the full input, 20767. So there's obviously a better way to do this that I did not realize. I should make sure that I added all the numbers correctly, I guess. All right, 5, 6, 30, 600, 50, 2,000, 70, 9,000, 2,000, 700, 3, and 3. 14,467. That's not what I guessed. 14,467. Okay. What's part 2? Okay. As you prepare to give the amphipods your solution, you notice the diagram they handed you is actually folded up. As you unfold it, you discover an extra part of the diagram. Between the first and second lines of text there that contain amphipod starting positions, insert the following line. So you have that. Still want to be organized. The least. So add that in the middle. That's pretty exciting. So that goes in the middle of this. I'm just going to do this by hand today. I honestly don't have any idea how the algorithm is supposed to work. So maybe. But the other thing is, like, I'm going to stop doing this in Notepad. Because I don't really have an undo in Notepad. Alright. So, given this, we want to move the D's as little as possible. Now I understand why we have double spaces here, because we're definitely going to need double spaces. Nobody is correct at the bottom, which is unfortunate. Right? So which row does it look easiest for us to accomplish? So we have B's and C's at the bottom, so very likely A or D is going to be easier to accomplish. So let's say I move D here. That's 1, 2, 3, right? So that's D3. And then I move A, because I'm just trying to get A's, right? I think that's what I'm going to try and do. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so that's A10. But the only way to get A's in here is to get everybody else out, right? That actually implies that that's probably not the right answer to the problem, right? Because we're going to want all this extra space. So we definitely want to solve in the middle first. So let's solve in the middle first. All right, we know which one's going to be easier, B's or C's? C's, I guess? No. I'm really skeptical about wanting to move these D's around as very much to begin with. Because they're really expensive. Right, I could get a solution, but then it won't necessarily be the best solution. Which means I guess we're after B's. Okay, so if I'm an A, and once I'm out in the hallway, I never want to come back. Right? That means we've got 1, 2, 3, 4, 5. There's an A5. And then you are going to be 1, 2, 3, 4, 5, 6. So that's an A6. I don't... So it says we're not allowed to stop over top? Is that correct, right? And they'll only go into the final place. Okay. We'll never stop on a space immediately outside of any room. Move into that space so long as they immediately continue moving. Never move from the hallway into a room unless that is their destination room, and that room contains no amphipods which don't belong there. Right. So that means this problem probably only actually has one solution. And I can't put this B, like the best place I can put that B is probably here. All right, so let's do that. 1, 2, 3, 4, 5. So let's try B5. This A needs to get out, and it can get all the way over here. All right, so that's 1, 2, 3, 4, 5, 6, 7. So that's A7. And this B can stay there until it's time to bail, which means this C, 1, 2, 3, 4, 5, 6, 7. All right, so now we've got C7. This, yeah, so then this B has to come up here. 1, 2, 3, 4, 5. I don't know why I took the insert off. 1, 2, 3, 4, 5. Okay. So your B5. No, that doesn't work. But what I can do is I can put it there, which is also a 5. All right, and then this C, 1, 2, 3, 4, 5, 6, 7. That's C7. All right. Except now I'm stuck, aren't I? Because I don't know where to put this other B. I can't move it. So if I were to put this B here, yeah, see, that's a problem, right? Because then I've got nowhere for the C to go. If the C goes here, so I could put that B there. And the C's got nowhere to go, and the B's got nowhere to go. Yeah, so none of this is right. So instead of trying to build the B's, let's see if I can build the C's. Okay. I still think the best thing for... So I'm trying to build the C's. I'm trying to get these guys out of here, right? But also to find ways to get the C's in there. Man, the C's just seem really impossible. What was their... So their walkthrough for this part 2 was D, A, B, B, A. Yeah, so it helps that they had one already correct at the bottom. All right, and I don't have anything correct at the bottom. This is the same puzzle input, right? They didn't just magically give me another one, right? So yeah, that, I mean, theirs looks really obvious. I mean, I could brute force this somehow. I just don't know if there's too many combinations for the brute force to work. The other thing that's interesting is they're not quite filling everybody up. But that's okay. So maybe I need to try and not focus on solving one entire stack. Like, it's okay to bury something so that it comes back later. So burying these D's over here, for example, is probably no different than burying them here, right? Because if I go 1, 2, 3, and then I got to go 4, 5, 6, 7, 8, 9, 10, 11 to get them there. So if I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 to get them back there. So burying them on either side is acceptable. Maybe the D's are what I should be focused on. Empty this out because this big stack of D's is really valuable. Right? So if I do this, 1, 2, 3, right? So then that's D3. Go over there, D3, right? And then this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so that's A10. And then this, 1, 2, 3, 4, C4. Then this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's B11. Right, and then I start moving these D's over. So they're 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So each one of those is 11. D11, D11, D11. Now what's next? So I have this C here that I don't know what to do with. If I get it out, I can start moving A's in. But the best place I could get it would be like right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's try that. So now I've got 1, 2, 3, 4, 5, 6, 7. I've got 7. And then I've got 1, 2, 3, 4, 5, 6, 7, 8. I've got 8. Can't move the B out of the way of the A until B's are ready to be done. And I can't do that until these are out of here. Hmm. All right, so the best thing I could do with that B is put it there, and now I've blocked off A's. So if I put that C there, then I put that B there, now we've killed all the C's. But I don't see how I get here without doing pretty much exactly what I did. Yeah. All right, so that's that C9. Let's get rid of these D11s. DACB, huh? DACB, huh? Definitely think this is right. 1, 2, 3. Definitely think that's right. All right. So last time I put the A over there, which I guess means let's put the A over here this time. So that's an A3. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's a C11. And then that will also be a B11, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. B11. And these were 11s. And these are 11s. So our plan now is to try and get A's. So I have a C that's in the way. So if I put a C there, then I'm in trouble. I can get the A and the A. That A will have to stay. But let's try it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoops. So you're C9. All right, and then you are 1, 2, 3, 4, 5, 6, 7. Which means you should be 8, right? 1, 2, 3, 4, 5, 6, 7, 8. Now I have this A that's buried here and this A that's buried here. So if I move this B here, and this A here, then I'm stuck again. I wish I knew what this algorithm was so I could look it up. But that's not going to work either. It's tempting to do all the D's because they're easily available. What if I buried them all? If I buried them all, then I could take a C out here, which would move an A and an A. But then I have this. What if I don't bury them all? What if I leave that one? Okay, so let's do 1, 2, 3. Alright, so that's D3. Let's do 1, 2, 3. That's D3. And let's move you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you're D11. What if I move this C? You should also be 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Alright. Now I can start moving A's. 1, 2, 3, 4, 5, 6, 7. A7. 1, 2, 3, 4, 5, 6, 7, 8. A8. Now what? If I move this B here, 1, 2, 3, that means I can move this A. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's A9. Now, the next best thing would be to start moving C's, right? 1, 2, 3, 4, 5, 6, 7. So B7. All right. Oops. 1, 2, 3, 4, 5, 6, 7, 8. That would be C8. Problem is, now what? This B goes there, and then I'm stuck again. I mean, I do generally like this pattern. What if I move the D? Well, so the problem is if I move the D there, then I stop being able to move the A. That's why I wanted to move the B there. What if I move the C here and the B here? Then I've got nowhere to move the C. So what if I move the C here and the B here? And then I move the C there. Well, okay, that might work. 1, 2, 3, 4, 5 for the C. All right. And then 1, 2, 3, 4 for the B. And then the C. 1, 2, 3, 4, 5. And then this B. 1, 2, 3, 4, 5. All right, and then this B. I'm going to be stuck again now. 3, 4, 5, 6, 7. There's that B. Now I have an A I can't do anything with, and a B I can't do anything with. I'm guessing that the purpose of this problem being so hard is that I can't do this. Like, I am going to have to brute force this. And the question is the brute force going to be done in time? I have no way to get that A over there. We know that B's are a problem because, we got B's sitting on the bottom. But we had C's sitting on the bottom over here too. They're obviously a problem because of that. Curious if anybody on my lists has finished this. I got 64th doing it by hand. First time I've hit the leaderboard. So we got a few people who have done part 1 and nobody who's done part 2. Like, what am I noticing about the pattern here, right? Pattern of burying the D's on the right and the A's on the left makes a lot of sense to me. So what they're trying to do now, by moving the D and the A out, is they're trying to get to the C's, because C is already good. Alright, so they throw a B here, they throw an A here, and then the C's come over. But now this last C is stuck, so you just wait. So you throw a B here and a D here, so that this B can come down, this B can come down, this B can come down. So then the other pattern we see here is like this, where we have a string of things just sort of waiting to be played. Let's see if we can find anything like that for us. What did I do last time with the 3Ds? Put them up there and there. What if I do that one, but then move them over there? So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's a D10. And this is also going to be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now that's 10. Which then allows me to put the C here. 2, 3, 4, 5. All right, so C5, which then allows me to start putting A's in. 1, 2, 3, 4, 5, 6, 7. And then that's going to be 8, right? 1, 2, 3, 4, 5, 6, 7, 8, right? But what now? So having a C here ready to drop into here would be great. But we could also end up building B's up here ready to drop into B when they're ready. So let's try that. 1, 2, 3. All right, so now this A moves over. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's the A. Now, if I wanted to have a bunch of C's ready to come over, first one would have to go here. All right. Well, I mean, it doesn't have anywhere else to go. You can't put it there because then the B isn't going to work. So what if I just move the B out, actually? 4, 5, 6, 7. If I put the B there, all right, then I've got 1, 2, 3, 4, 5, 6, 7, 8. C8. I want to make sure I counted that correctly. 1, 2, 3, 4, 5, 6, 7, 8. Okay, good. Now I have a B that I can't place. All right, because if I move that B here, then the C is stuck and we're done. So that can't be it. How are you doing this by hand? Yeah, I'm just like in my head. I don't know the algorithm. I don't even know what to search for. So there you go. Let's move that B back there. Good luck, he says. Thanks. Yeah, I did part 1. I got 64th place on part 1. By hand. Let's see. Can't move this D out to get this A over there because A is all the way over here. So there's no sense even thinking about that as an option. So that C was there. What if I leave that C there? What if I'm really, like, I did think that I would just bury all the D's and that would be the way to make it happen, but that's probably not right either. So the alternative would be for the C to go up there then, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. And now move the A's over. 1, 2, 3, 4, 5, 6, 7. All right, and then we know this is 8. We've done this enough. We know that's 8. Now if I move this B, 1, 2, 3, 4, 5, 6, 7. I move that B there. Alright, now I can move that A out. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's A9. Now I can move this B, 1, 2, 3, 4, 5, 6, 7, right here. Right, and now this C can drop in. 1, 2, 3, 4, 5. So there's a C5. Now what? Now this C moves over. 2, 3, 4, 5, 6, 7. So that's C7. I think I got this. I think I see it happening. Okay. 1, 2, 3, 4, 5, 6. So that's a B6. All right, and now we've got this C. 3, 4, 5, 6, 7, 8. So that's a C8. All right, and now the B's can start moving in. So there's 1, 2, 3, 4, 5. There's B5. And then this B can move in. 1, 2, 3, 4, 5, 6. That's B6. All right, and this B can move in. That's 1, 2, 3, 4, 5. That's B5. Whoops, put the B there. Too excited. Now, we move the D. 1, 2, 3, 4, 5, 6, 7, 8 over there, D8. And we move the A. 1, 2, 3, 4, 5, 6, 7, 8, 9. A9. Move the C. 1, 2, 3, 4, 5, 6. And then we move the B. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9. And then the D's. 1. It doesn't think it matters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11. Alright. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's another 11. Alright, and then we've got 1, 2, 3, and 1, 2, 3. So 2 more D3s. Okay. Calculator. Clear. 3,000, 10,000, 10,000, 900, 7, 8, 70, 9, 70, 500, 700, 60, 800, 50, 60, 50, 8,000, whoops, 8,000, 9, 600, 90, 11,000, 11,000, 3,000, 3,000, 62983. Okay, that wasn't the answer. We have the history here. Let's make sure all the numbers were correct, at least, in the history. So we've got 3,000, 10,000, 10,000, 900, 7, 8, 70, 9, 70, 500, 700, 60, 800, 50, 60, 50, 8,000, 9, 600, 90, 11,000, 11,000, 3,000, 3,000. So the only thing I can think of is that these D moves could be made better. I have a notepad open already, right? Come here, notepad. All right, so these D moves could be made better. Like maybe instead of moving these 2 of them over here and 1 of them over here, can I move 2 of them over here and 1 of them over here? Can I start with that? And that's really the only thing I can think of, because these are the things that are going to kill me in terms of optimization, right? And I can't... I'm going to end up with these at the end. I don't think there's any question about that, but we'll see. All right. Backwards. Okay. So, 1, 2, 3. That is a D3. All right. 1, 2, 3. That's a D3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's D11. Right. What did I do next? I moved the C to 9. C9. 3, 4, 5, 6, 7, 8, 9, 10, 11. So that would be over there now. C11. That'll get the A's down here. So there's 1, 2, 3, 4, 5, 6, 7. There's an A7 and an A8. We've done that just too many times to not know that. Okay. And then I moved B and A and B. So this B, 1, 2, 3, B3. All right, and then this A, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 A's. This B, 1, 2, 3, 4, 5, 6, 7. And this C, 1, 2, 3, 4, 5, 6, 7, 8. C8. And then this then what? Now, so I moved the B up there, then I'm stuck. How'd I get stuck? All right. That C11 seems like an inevitability. Yeah, that one, I mean, that one seems reasonable. All right. So this is A7. This is A8. What if I go C, B, but then I'm still stuck with a C? I go C, B, C. I mean, it seems like I can't unbury this D yet to get this A. If I have to do this, and I can't put that B over there to get this A. Right? This A, 2, 3, 4, 5, 6, 7, 8, 9. It's now A9. Oh, so move this B. 1, 2, 3, 4, 5, 6, 7. Did I just... No, that's... Yeah, because then I move the C and then I've got this B and I'm stuck. Yeah, so this doesn't work. Oh. Can't move the A's out of the way. Well, that's not entirely true. So I could move this D out of the way, right? 1, 2. Now I can move this C out of the way. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, see, I'm burying that A again. Now I've got A7 and A8. Now I've got nowhere for this B to go. And I can't unbury the B's either. All right, let's stop assuming we have to move the D's. All right, what would be the other thing to move? We could move the A's over here, and then move the D's. All right, 1, 2, 3, 4, 5. So that would be an A5, which would make this an A6. An A6. So if I move DD, then I've got to move DC. And I can drop the A's in. I can try it. I don't think it's right. So there's a D9. And there's a D9. Wait a minute. Wait a minute. These were 10s. Did I just do this wrong? Possible I did this wrong? Like I had the right answer, but just like recorded it wrong? So you're going 1, 2, 3. You're going there. Oh, no. No, you're not going there. You're going here for 10, for 9s. All right, you're going to go there for 9s. Because, yeah, that's it. So then that's D5. And then the rest of it should be the same. I don't know, let's see. All right, so clear. Actually, what's the history? So this was this, just so we know what the history is. All right, 9,000, 9,000, 5,000. All right, because 18.5 is 23. Well, that is 23 over there too, isn't it? Yeah. I ended up with a C9. Yeah, that had to be there in order to work. 9 is 18, and 5 is 23, 10 and 10 and 3 is 23. Fine, let's put the C here. I don't think that works, but 2, 3, 4, 5. C5. And then we start moving A's. That's the A7. Oops, lost our caps. That's the A7, and then the A8. Right, and then the B7. So I had put the B over there, but I think I need to put the B here now. 1, 2, 3. And now the A moves over. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's an A9. Now I need the B out of here. 1, 2, 3, 4, 5, 6, 7. So that's B7. Now I can move the C over, but this is going to get me stuck, isn't it? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so this gets me stuck. Because I have nowhere to put B's. I have nowhere to put this B. I suppose the other thing to do is make sure that when I ran this last time, I counted it correctly. So let's do that. So this is a C, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, and then this is an A7. So C9 and A7, and this is A8. 2, 3, 4, 5, 6, 7, 8, yep, and A8. And then we move the B. 1, 2, 3, 4, 5, 6, 7. Right, that kept the B out of the way. And then we move the A. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's an A9. Right, and then this B. 1, 2, 3, 4, 5, 6, 7. B7. So far, it's correct. Can't place a letter above a letter. You can only place a letter above a hashtag or into its final position. All right, so 1, 2, 3, 4, 5, 6, 7, 8. So that's C8. 7. C8. 89. B7. C8. So I had C5 over here because I moved this C first. But I think if I just do this now, it should be a 4, right? 1, 2, 3, 4. So C8 and a C4 is 12, just like C5 and C7 was 12. And then this B has to be a 6. 1, 2, 3, 4, 5, 6. All right, and then this C, 1, 2, 3, 4, 5, 6, 7, 8. So B6, C8. Okay, still looking the same. And now we've got 1, 2, 3, 4, 5. So there's a B5. We have 3 of these to move now. Should be the same. So I did B5, B6, B5. 1, 2, 3, 4, 5, 6, 7. Which would then be 1, 2, 3, 4, 5. Wait a minute, that can't be right. 1, 2, 3, 4, 5, 6. Oh, that's right. B5, B6. And then this is 5, right? 1, 2, 3, 4, 5. But if I did it the other way, it should end up being the same. Right? I've already done my B5. So here's my 1, 2, 3, 4, 5, 6. Yep, it's exactly the same. And then this one moves, which is 1, 2, 3, 4, 5. Next I moved D so that I could get the A. This is really the only choice. I don't have any other choice. 1, 2, 3, 4, 5, 6, 7, 8. D8. A is 1, 2, 3, 4, 5, 6, 7, 8, 9. A9. C is 1, 2, 3, 4, 5, 6. C6. So far, nothing's messed up. 3, 4, 5, 6, 7, 8, 9. Another B9. And then the D's. which are 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 5, 5, 9, 9. D5, D5, D9, D9. So that's 28 Ds, and over there is 22, 25, 28 Ds. Yeah, so it basically comes out the same. So I didn't make a mistake, which sucks. Because I hoped I had made a mistake. I can run the calculator again, but I'm sure I'm going to get the same answer. So 9,000, 9,000, 5,000, 900, 7, 8, 70, 9, 70. Wait a minute. 7, 8, 70, 9, 70. Yep. Okay. 800, 400, 60, 800, 50, 60, 50, 8,000, 9, 600, 90, 5,000, 5,000, 9,000, 9,000. 62983. So the exact same number. So that's clearly not it. I mean, I guess I'll go back to the page and make sure I didn't mess up my input. 62983. 62983. Your answer is too high. Alright, 62983. Answer is too high. Well, I mean, obviously. Can't be too low. Well, I guess it could be too low if you did it wrong. So the only other option other than burying the D's would be burying the A's. Well, maybe. So there's an A5. There's an A6. Now, if we were trying to get B's in here, what we could do is we could put the C up here. 1, 2, 3, 4, 5, 6, 7, 8. All right, we could do C8. Then we could get B. 1, 2, 3, 4. There's a B4. And then bury that C over there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now this is 1, 2, 3, 4, 5. That's a B5. All right, and then this 1, 2, 3, 4, 5, 6, 7. That's a B7. Now I could move the A up here to move the B. But then I've got nowhere to put all these A's. I really want to be able to get these C's out of here. Oh, actually, that's fine. No, I can do that. That's right. 1, 2, 3, 4. No, I can't put it there. I have to put it here. All right, 1, 2, 3, 4, 5, 6. So there's an A6. Now I can move this B. 1, 2, 3, 4, 5, 6, 7, 8. So there's a B8. Now I can move C's. All right, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now what's next? I can't... this actually is probably a blocker. Like, I probably killed myself here, didn't I? Because now I can't move any of these out. Yeah, I can't do that, because then I can't move any of those out. And if I put the A there, then basically what you're saying is I have to move all of these out in order to get the A's. And the only way to get the C's out is to move out the A and the B. So the only place to put the A is either here or here. If I put it here, I can't get the C's out. And then I have a D and a D, and I'm dead. The D is for dead. Yep, so that strategy doesn't work. God, I wish I knew what an algorithm was. Because I have a feeling like a brute force is just going to take too long. So we tried moving the D's. What if we tried moving the A's to opposite ends? So let's do... Actually, what if we put all the A's over here? Alright, so let's do that. Let's do 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 6. So A5, A6. Now, if we want to unbury the B's so that we can get to the C's, feel like I could put a B here, right? So that's B3. I can drop this A over there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's A9. And I can drop this B, 1, 2, 3, 4, 5, 6, 7, 8, 9, over here. And I can do 1, 2, 3, 4, 5, 6, 7, 8. That's a C8. And then this B, 1, 2, 3, 4. And then this C, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I start dropping the B's in. So there's 1, 2, 3, 4, 5. That's a B5. And I've got 1, 2, 3, 4, 5, 6. That's a B6. And then this is a 1, 2, 3, 4, 5. That's a B5. Now what? So if I throw the D here and the A here, then the C and the B can come out. But the problem with that is D, A. Then I have an A and a D, and I have no way to get D's over here. So if this is going to be the solution, then the D's have to come over here. So that would be D, 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 C. But then I can't move any of the A's. Oh, but I can move this A. I can move this A over there. 1, 2, 3, 4, 5, 6, 7, 8. Can I move that A? I don't know if that's legal. As long as I'm moving into an unoccupied open space. Okay. Never move from the hallway into a room unless it's their destination. That starting room is not its destination room. It can stay in that room until it leaves the room. So if it starts moving in the hallway, it will stay in that spot until it can move into a room. So I can't move that A. Once the FPod starts moving, any other FPods currently in the hallway are locked into place and will not move again until they can move fully into a room. That's vague. That's vague. Yeah, maybe it's not as vague as I think it is. Once an amphipod stops moving in the hallway, it will stay in that spot until it can't move into a room. So, yep, that's not legal. So I can't do that. Because it certainly would solve the problem. If this A was over here, I could move this D up here. Actually, it probably wouldn't solve the problem, because then I'd have to put the A here. Oh no, because then I could move the D in. Yes, if I could move across the hallway, then it'd be okay, but I can't. So this looks like a dead end again. Yeah, this looks like a dead end again. Alright. Back to go see if anybody I know has finished this. One finisher. So it's doable. What does the regular leaderboard look like right now? That's just the... I want the scores for today. I don't know if I can do that. Settings, personal stats, private leaderboard, personal stats. That's this page. Oh, per day. There we go. It's staring me right in the face. Alright, well, obviously more than 100 people have already finished it. So, it's doable and in a reasonable amount of time. So there's obviously some kind of an algorithm. What would that algorithm look like? Yes, I did part 1 by hand. I mean, I feel like they made part 2 difficult enough to do by hand, knowing that some people would do part 1 by hand. Alright, so what is the brute forciest algorithm I could possibly do? Given any particular piece... Given any particular... do yours for you. That's okay. Given any particular piece, there are really only 3 moves. All as far left as you can go, as far right as you can go, or into your destined spot. Which means every potential piece, every movable piece, of which there are 4 movable pieces, you can try those 3. You can try those 3 moves. And then that just gives you a new board. I mean, I guess that's what it is. Why you open day 18? Alright, you can be over here. You can be over here like this. I don't even care about reading the data. Like I can just throw the data in there. I also don't care about part 1. Right. So essentially, what data structure would I use? I could use the board could be a dictionary of X, Y to a nullable character. All right. And so then we would start with let's see. Right, 1, 1, 2, 3. So 3, 2. 3, 2 would be D. And 3, 3 would be D. And 3, 4 would be D. Actually, I don't need to be a nullable char because I'll just, the spots that don't have anything in them will just be not in the dictionary. Alright, so then these are 5. Cut it out. 5, 7, and 9. Okay, now you're killing me, Smalls. So your A, your C, your B, and your C. Your A, your B, your A, your B. Your D, your A, your C, your B. Now, legal spots. It's going to be a hash set of int x, int y. Alright. So this is going to be 1, 1, 1, 2. Wait a minute. X, Y, 2, 1. 4, 1. Alright, so this is the hallway. 6, 1. 8, 1. 10, 1. And 11, 1. So this is the hallway. And then we've got 3, 2, 3, 3, 3, 4, 3, 5. Actually, I think I'm going to keep these as separate things. Alright. Then we've got column A. This is a new hash set of int x, int y, which is 3, 2, 3, 3, 3, 4, 3, 5. And then B, C, and D. 4, 5, 6, 5, 4, 4, 5, 6. Whoops. Sorry, this is wrong. I did that wrong. This is what I meant to go up with. 3, 4, 5. 3, 3, 3, 5, 5, 5, 5, C2, 3, 4, 5, 7, 7, 7, 7, 2, 3, 4, 5, 9, 9, 9, 9, 2, 3, 4, 5. So legal spots is going to be, alright, legal spots, add range. Can't do add range on a hash set? Alright, hallway, concat, column A, concat, column B, concat, column C, concat, column D, to hash set. So those are all the legal spots. So what are the rules? So the rules are, what are the things I need to know? I need to know the movable pieces, right? So the first thing I need to do is I need a list of x int y char c get movable pieces, right? So I want to know which pieces on my board are movable. And then, given the board, I need a list of int x, int y of get legal moves for a piece. Excuse me. You drink some water. Or Fresca, I guess. Right? So, you need to be able to get the legal moves. Sure. Get the movable pieces. So what am I going to do here is I need to know is the board finished? All right. This one should be easy, right? It should be all of these. So I should say column A, all, board of C is equal to an A. Right? And column D, column C, column B. Every one of those is a B, a C, and a D. That's how you know the board is finished. Assuming I know how to do these things. Do I need to keep a copy of the board? I probably do. So this probably needs to take the board. Because I foresee myself so I foresee myself needing recursion here, right? So for each movable piece and movable pieces, All right, let's say right. So for each movable piece, what I want to do is I want to say score is solve the board. New board. Yeah, solve the board. If score is greater than 0, let's see. Now let's say result is 0. So yeah, if score is greater than 0, then we want to say, just for fun, solved it with score points. Alright. And if result is less than the score, then the result is equal to the score. We return the result. So you get movable pieces of the original board. Solve the board trying to move a movable piece. So long solve board. Here's our board. All right, here's our board. Here's our piece. We need a new board. Well, not yet. We will need a new board. So for each time we come through here, we want to get the legal move and get legal moves for the board and the piece. All right, we will make a new board. Our new board is new, one of these, which will start with a copy of the existing board. All right, and in a new board, we're going to remove piece X and piece Y from its place. All right, and then we're going to put it in its new place. So its new place is going to be a legal move, right? So the new board, when the legal move is an XY, so new board sub legal move X, legal move Y is now equal to piece C. Okay. So now we have a new board. We need to solve it again, which means we need this again. We need this again. Which means maybe this. Yeah. This becomes solve board of board. Okay. Right. So this now is our board. We need result is 0. Return the result. And then here, every one of these legal moves, we're going to do the same thing. Alright, so we're going to do this. Score is going to now be solve board of the new board. If score is greater than the result, and the result is equal to the score, return the result. So that's our recursion. You're just telling me I can't have overloads. Sub solve board. Sure. I feel like I need to keep a running total. Because like I have no idea when I make these moves, these totals need to be running, right? So the legal move for this also has to return us the cost. Total plus the legal move and the cost. You can start out at 0, that's fine. Alright, so if I move that, then it's there. So I think what I want here is also, after I make a legal move, I need to say if the board is finished, which, by the way, you need to take a board. Alright. So if the board is finished, then I total plus legal move cost. Because that last move just finished this board and we're done, and that's how we get out of the recursion. Now this if the legal moves count is 0, this is the other way we get out of the recursion, right? Because we return 0. Actually, that was already being handled here, wasn't it? Kind of. I actually don't know. I think I'm close, but I'm not 100% sure. So let's step through this. Okay, so to solve the board, here's a board. Here's the running total. Find me every movable piece on the board. Try and subsolve that board. If we subsolved that board, All right, this is why we need this to say, here's our result. So if this returns 0, then basically it means the path you were down led to no solution. But we have a bunch of legal moves that could potentially result in a value, which is also why we have to keep the result here. So this should be the real whole value because we come into subsolve board, and this is always total plus legal move cost. Right? So this should always return the full value. Which means this is correct. And then we have this. This probably really belongs here. This breaks out because it only looks at movable pieces. Okay. So let's find the movable pieces. I know I'm just going to have to like brute force this, which kind of sucks. All right. So basically every piece that is at the top of the stack right? So by the way, this is wrong. Holy smokes. That would have made me very sad to realize that. These don't have to be hash sets. These can be lists. Probably should be lists. So every all right, let's do this. I'll do this. Do this. 48759. Sorry. I don't know why you're sorry. But okay. I want a print board. Because it's definitely going to help me in debugging. So we have spaces. We always have a dot. We have two. We have a space. We have a space. We have a space. We have a space. We have a dot and two spaces, and then a hash. Right, and then we have three hashes, and then a space and a hash, and a space and a hash, and a space and a hash. All right, 1, 2, 3, 4, and then three spaces. Then three more of these, except like that. Then this. Okay, so this is going to be board of, let's see. Yeah, that's kind of a bummer, isn't it? I suppose what I should do is every piece of the board that doesn't have a letter in it should have a dot in it. Whatever. Display. We'll just do display. Board. Your 1, 1. If not board, try get value x, y out var c, then c is a dot, return c. What's your problem? Oh yeah, you need an x and a y. X and y. So you're board 1, 1, you're board 1, 2, you're board 1, 4, you're board 1, 6, you're board 1, 8, you're board 1, 10, 12, and 13. Our hallway. Damn it. Went backwards. 1, 2, 4, 6, 8, 10. I missed this. It should be 12 and 13, not 11. And of course I have all these backwards because I'm dumb. 2, 1, 4, 1, 6, 1, 8, 1, 10, 1, 12, 1, 13, 1, right? 1, 2, 4, 6, 8, 10. Wait a minute. 1, 2, 4, 6, 8, 10, 11. Why do I think I have more than I have? Wow. I guess I counted correctly the first time. It's 4 of those, right? Whoops. So this is going to be... What do we decide this was? This is a 3, 2. Alright, so this is 3, 2. 3, 3. 3, 4. 3, 4. 3, 5. D, a board of 5, 2. 3, 4, 5. Now you're 7, 2. 3, 4, 5. And now you're 9, 2. 3, 4, 5. So after all of this, can we print the board? You should be the starting board, by the way, so we don't confuse you with all the other things that say board. Okay. Do we print starting board? What's the problem? Okay, D, 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 C, A, C, B, C, A, B, A, B, D, A, C, B. Okay, so we printed the board. Okay, so what are our movable pieces? Our movable pieces look like our movable pieces look like the top of any stack, right? And then anything that's in the hallway. So, result, add range, board, where the Y is 1, so everything in the hallway is potentially movable. Key X, KVP key Y, KVP key C, yep, KVP value. All right, you're a KVP. All right, then we want the top of the range. So result, add range. Probably can't quite do it that way. So we'll say board where the X is, what do we decide? 3, 5, 7, 9. So the X is 3, and the Y is greater than 1. X is 3, and the Y, key Y is greater than 1. So give me the first one of those, and yes. Now we're going to have to do where, not first. We're going to have to do an order by. Y. And then let's select this. First or default. Let's see. Column A top. Let's see what happens the first time we run through that. All right, so we've got nothing in the board here, but the top of column A should be 3, 2D. All right, should be 3, 2D. So if column A top is not equal to null, let's see, that there's a optimization here, which is don't offer to move anything in its final place. Actually, we're going to do that right now. So first, the defaults. So you're going to be, since you're that, X, Y, and C. Right, same with you. X, Y, and C. So if your X is not equal to 0, because we'll never get zeros, and I want to say if not column A all, board, is that an XY already? It is an XY, right? So if we found one, but it's not the case that either the board contains key XY, so if all of that turns out to be true, then you can go into the results. Right? So at the moment, the result should contain, yes, all of yesterday's nonsense. Go away all of yesterday's nonsense. And this is .NET, of course, for no good reason saying, hey, it's not safe. So that's a legal move. So now we have B, C, and D. So you're 5, 7, 9. Oh, you know what I should do here? This is dumb. I have column A. I should use column A. Instead of this dumb math. Column B. Column C. Column D. Don't offer us anything that looks correct. Column D, column C, column B, column B, column B, column C, column C, column D, column D. Okay. So our result now should be DAAD on the top. I'm going to do a little bit of futzing here. Let's say that was all D's. And we should have... No. See, this one shouldn't show up. Oh, those are supposed to be A's. Ha 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 ha. Of course. Yeah, of course that's totally legal. Let's make these all A's. Alright. So now the A doesn't show up. Good. Let's make this half A's. And the A still doesn't show up. Okay, good. That's what I was hoping to see. Okay. So there's all my movable pieces. Now what are my legal moves for a given piece? So, if you're in the hallway, so your Y is 1. Let's see. If you're in the hallway, then your only legal move would be into your column. Would be the bottommost piece of your column, but you have to be able to get there. Right? But you have to be able to get there. Let's ignore the hallway for a moment then. All right, so if you're in one of the columns, then let's see, look left, look right. So if you're in one of the columns, then so your X is going to be our hallway X's is hallway select XYX to list hallway. Right, so if we're going to look left, then you're going to be in piece X minus 1. Something, 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 right? While X is less than while X is greater than 0. So our first set of costs are going to be, you need to move up All right, so piece y minus 1. All right, because if you're here, then it's 1, so that's 2, 3, 4, 5, right? So okay, if a hallway contains x1, hallway x's, if hallway x, what the hell did I call that thing? Alleyway, I wonder. Hallway x's contains x, so only look in spots that are legal. If, let's see, so we say if the board contains x comma 1, then you're done. You're done moving left. Contains key, by the way. That's what that should say. Otherwise, let's see. Last legal is blank -1. Last legal is x. If last legal is not equal to -1, then result add. You want to just keep going all the way to the left as far as you can until you can't go there anymore. All right, so that'll be x1. And then if last so you're going to go up and you're going to go over 1, so your cost is actually piece y. That's fine. So if your last legal is not equal to -1, then your cost is increased by the difference between and x, and then last legal now becomes x. So that's the cost. Can't use x because it's not here in this context. Fine. There's x. Now we look right, which is basically the same thing, which is cost, your last legal is -1, except now we're going right. We want you to be less than, what did we decide that was? That was 11, so less than 12. And we want you to go right, and if it contains this and the board contains it, then you're done. Otherwise, this goes this way now, and you get added. Okay, so that's how we move column pieces. Let's ignore the hallway for the moment. It's going to be very similar, but I want to see this work. So let's say get legal moves. Let's set a breakpoint here. Okay, so the piece we're looking at now is D. So going left, we should see 1, 1, and 1, 2. 1, 1, and 2, 1, sorry. So, start here, the cost is y. It should be 2, right? Because we're going to try and go up and over. All right, so our cost is 2. Our last legal is -1, and our x is now 2. Hallways does contain 2. The board does not contain anything in 2. We've already counted for the cost, and so now our last legal is 2. We're at 1. Hallways will contain 1. Board doesn't contain anything. So our cost should go up by 1. And now the last legal is 1. So that gets into the result. Okay. All 1 and 3. All 1 and 3. Oh, this should be last legal. Fine. And then we do it again. This is going to be last legal. Right. So let's go here. Right, so that is now 1, 1, and 3. And then we should get 11, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. That should be a cost of 9, right? Did we get a cost of 9? We did. Okay, so let's step out of this. Shift F11. We got no legal moves. Oh yes, that's right. No, that's wrong. Did we not return the result? We did return the result. I don't understand that. Get legal moves forward piece. Okay, I don't understand. That should have contained 2 legal moves. Yeah. 1, 1 for 3 and 11, 1 for 9. Okay. Legal moves count, so that's not there, no problem. So for each legal move, okay, so you don't care. Don't care. So there was a legal move. There's a legal move. There's a legal move. There's a legal move, but only 1. Oh yeah, because I of course bailed. Three, 2 is not in the dictionary. So we had D there. And we recursed in, we had D there. 3, 2 is not in the dictionary at line 200. Line 200. Ah, yes. Try get value. Out var C, and C is A. Try get value of this should be an XY. Thank you. The value of XY. Okay. Interesting. I feel like let's see if we can track a little bit of this. All right, so we're moving the D, we're moving the D, removing the D, removing the C, removing the A, removing the C, removing the B, and then we backed off because that didn't work, so now we're moving the A. And then we backed off because that didn't work. Wait a minute. All right, and then we back off because that doesn't work. Okay. Let's do this. That's kind of what I want to see, right? This board ended in a stalemate. Why is that a stalemate? Why is that a stalemate? What am I not understanding here? Okay. Oh, because it's for a particular piece. Okay, so the first time we do this, all right, we do it for 3-2D. Makes sense. Now we're trying to do it for 1-1D, and it's in the hallway, which means it can't move. So now we really need to see what it takes to move into the hall. And if you're in the hallway, then your only legal move is to move into your column, right? Target column. Target, well, let's say target X, right? Switch piece C. I forgot how to do this. Switch piece C. Target X is -1. Alright, case A. The target X is 3579, right? Target X should be, how about this? 3 plus piece.c minus piece.c minus A times 2. Yeah, okay. Now we'll say, given that, we're going to say your X is your current X. It's plus, let's see. You want to head towards your well, x is not equal to target x. You want to try and head towards it, right? So I want to say x if, let's see, board contains key of, let's see, direction is, if you are to the right, you want to go -1, otherwise you want to go 1. X plus direction, comma, 1. Okay, if you find something in your way, you have to stop. Otherwise, x plus equals direction. So if you got to target x, the other thing we have to do is you can only move into your column if your column contains stuff. Right? So there's your target x. There's your x. Is the column a legal target yet? All right, then the answer should be index is 2, index is less than 6. If board, try get value at target x, comma, index. C is not equal to U. Then break. Okay, if we get all the way to 6, then we can do this. So if we get all the way to the bottom, and we got all the way there, we also need to keep a running total of the cost, right? So the cost right now is 0. We also need to know where the target Y is. Right. Okay, so if we manage to get there, then we're going to say cost plus equals target y minus 1, right? Because let's say you were here, right, and trying to get down in here again. So we look here, you're okay, that's 1. We look here, you're okay, that's 2. Now your target, you're at y, you're at 1, y, and you need to get down into here, that would be 1 more. Target x, target y, and cost. So the funny thing about the hallway piece is they always try and go in. These pieces that look left and look right should also try and go in. Right, because we want to be able to go from column to column. So they also need to run this. They also need to run this. So let's call this, I don't know yet, get move to final column. Right? And this is likely going to return this. So xy cost, int x, int y, long cost, nullable, because maybe not. Right? We're going to need the board and the piece. So there's our target. The only thing that needs to be set up is our cost, which is we need to be y minus 1, right? Because if we have to climb up, we need to do that cost. So like if this d was going over here, right, we're at y2, so there's 1, 2, 3, 4, 5, 6, 7, and then down 1 for 8. So if we get all the way out, then we're null. So this move to the final column. Final move is get move to final column of the board and the piece. And if the final move is not equal to null, then result add final move. So we need to do this always. Int x, int y, long cost. Right, we need to do this always. So instead, what we want to do is this in a column. So we can always try to move to our final column. In a column, we can also try to move out. So why are you not happy with that? Okay. Right, because, you know, some nullables are different than other nullables. Why not? So I think what I really want to do is every time we new board, let's sleep so these things don't come at us at 1,000 miles an hour, right? And let's see what happens here. So we have D, 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 C, A, C. We got A's and B's into the A and B column. Kind of impressed by that. I'm glad I can see that. And we move the B straight across. That's nice. This looks like it's doing the right thing. Oh, what if I let it run? How long is it going to run? It's probably using one core. It's not soaking up memory. Which seems okay. But we haven't gotten any solutions yet, which is bad. Do we use legal spots anywhere? Nope. We used hallway X's for sure. Did we use these columns? Yep, we used the columns. Did we use the hallway? No, not really. We could do hallway Y's though. Because when we're moving left and right, no, we use the hallway X's for that. So we don't really need the hallway Y's, do we? One, 2, 4, 6, 8, 10, 11. And now we don't use the hallway. I mean, I guess we can print the boards as we're finding them. Oh man. That was a bug. Alright, I mean, we're computing pretty fast, I think. I don't believe all these solves, by the way. What does this board look like? DDDC. What? Print board. New board. Say who and what? Show me this solved board, sir. That's a solved board. Ah, the cost is not correct. Right, the cost is not correct. Okay, so where are the places that we do cost? We do get legal moves gives us a cost, right? And so we also need a cost multiplier. It's going to be equal to new. Now it's going to be equal to the piece C minus A, right? 10 to the power of that. Math pow. Yeah. Log of math pow 10 piece C minus A. Much problem. Math pow's going to give us a double. Oh, expression term long. Why can I not cast that to a long? Oh, because remember what language you're in, sir. Let's make sure we get real cost multipliers on these things. So then also U. Let's find our first legal move. It's a D, so it's 1,000. Our cost is 3, so the actual cost is 3,000. That's all I wanted to know. So let's kill all of our breakpoints except for scores. So we have a board. And the last move is 14,000. So we solved it with 84,256. Okay. How many ways can we solve this? Is, I guess, the interesting question. Are we just solving it over and over again? Feels like it, doesn't it? Do we have our exit criteria for our loops correct? Let's not do this. Let's do this. New peak, score. Why are we seeing this over and over again? Oh. Is this my answer? I mean, I've kind of stopped. Answer is too high. Oh, guess what? You're supposed to go for the lowest answer, dummy. Let's see. Lowest is long max value. If the lowest is greater than the score, we have a new low. Turn to lowest. We can also bail out of here if total is already greater than the lowest score. Then we can return 0. New low is 0. That's no good. Score not equal to 0. Duh. Found an 84,256. Are we going to find anything lower than that? And I'm a little wondering. Exactly what's happening here. So for each legal move, moved from piece X, piece Y to legal move X, legal move Y, cost, legal move cost. Let's take a look at one of these finished boards. All right, what are all the moves in this finished board? I'm going to put those there just so I can see the new moves, right? these are all my moves. I come over here. Let's make sure we're actually solving the puzzle appropriately. You. Come back over here. Okay, so if these are my moves, then we moved D. So we moved D here. 1, 2, 3,000. Yep. 3, 3 to 11, 1. 10,000. 2, 3, 4, 5, 6, 7, 8, 9, 10. 10,000. Yep. And another one for 10,000. Yep. And then we moved C. Cost of 900. 2, 3, 4, 5, 6, 7, 8, 9. 900. Wow, this section is working. Which, by the way, let's talk about how shocking that is. Moved A from 5.2 to 3.5 at a cost of 11. 1, 2, 3, 4, 5, 6, 7. That doesn't seem right. 1, 2, 3, 4, and 5.2 to 3.5, right? Alright, so this should be 1, 2, 3, 4, 5, 6, 7. So that's a problem. So this direct move cost is wrong. So this should be 7. This is probably why we're having these problems, right? So then we moved A from 7.2 to 3.4 at a cost of 12. 1, 2, 3, 4, 5, 6, 7, 8. So that should have been 8. I need to know why. But I think those are the only ones. So 7.3 to 2.1 at a cost of 70. 1, 2, 3, 4, 5, 6, 7. Like that seems to be the only problem maybe here is these costs. All right. So let's this is the last thing, right? Get a move to final column. That's this. Okay. So for this, what I really want is I need to know the piece. Right. I need to know the cost multiplier. Actually, I don't. Cost multiplier should be 1, right? Cost multiplier is 1, right? Target X, target Y. So we're going from 5.2 to 3.5. All right. That's our X and our Y, so then we ended up at 3.6. Sure, because 6 is, we got off the edge of the board. Okay. So the column being a legal target is correct. All right, because our 5.2 to 3.5 at cost 11. So the cost here, 6 minus 1. Oh, that's no good. This should be piece Y. So you're going to show up with a cost of 11 or 7 now? Okay, good. So now show me the board. Clear everything. Give me the new moves. Okay. Not you. You. So here's the new moves. What is the score, by the way? Did we print out the score yet? Not yet. I'm going to let this run. Whoops. All right, I'm going to let this run. So 62983, which, by the way, we found that solution. Okay. So I have every reason to believe that that is the exact solution we found before. All right, I mean, I'm just going to let this run. As long as this is running, I'll go ahead and run this, but I'm pretty sure it's going to be exactly what we expected. D, 1, 2, 3, 3,000. Not bad. D for 10,000. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? D for 10,000. D for 10,000. C for 900. 1, 2, 3, 4, 5, 6, 7, 8, 9 to 900. A for 7. 1, 2, 3, 4, 5, 6, 7. A for 8. 5, 6, 7, 8. Yep. B. Oh, we ran. Oh, we found new lows. Ooh, hello. Oh my god. Brute force. Man, that took a long time. And yet I still ended up, 3 hours in, still ended up at rank 1000. Alright, I'm the first one there, and I'm the third one here. Okay, well, I mean, I guess if it takes 2.5 minutes, it takes 2.5 minutes. Well, I'm kind of bummed that I spent an hour doing it by hand, only to realize that the brute force solution was going to work. But you know what? Sometimes the brute force solution works. And I'm also glad that I stuck it out instead of bailing like I've done in the previous few days, especially yesterday. So, there you go. The answer is we did find an answer, and we just beat the crap out of it. Probably could have done faster if we'd paralyzed somehow, but 2.5 minutes, not so bad. Not so bad. Why do you want to mark like a square? You shouldn't mark like a square. Line wrapping selection. Yes, mark like lines. There we go. All right, cool. Well, I guess that's it for today. Day 23 in the bag, day 24 tomorrow. I'll see you then.